up, everybody? This is Tech G back with another video. And in this video, we're going to be talking about natural language processing. So let's get into it. Have you ever asked Siri to set an alarm, or have you told Alexa to play your favorite song, or have you used Google Translate to understand a foreign menu? If so, you've already interacted with one of the most fascinating branches of artificial intelligence, and that is natural language processing. Now, you might be wondering, exactly what is natural language processing? Is it just chatbots replying with cheeky answers? How does it actually work? And why is it so important in the AI world? All of those are great questions. And in this video, I'm going to break down the fundamentals of NLP, or natural language processing, and explore how it powers chatbots and translation tools, and give you a peek into how machines are learning to understand human language, which is arguably one of the trickiest things that they've ever been asked to do. So with all that being said, let's go. All right, so exactly what is natural language processing? Well, this is a branch of artificial intelligence that focuses on enabling machines to understand, interpret, generate, and respond to human language. In short, it's about teaching computers to talk with us and understand what we're saying. So think of NLP as a bridge between humans and machines. We speak and write in complex, messy, and nuanced language. Machines, on the other hand, they speak in ones and zeros. In NLP, this helps translate between the two. And it's not just about language recognition. It's about understanding meaning, context, intent, and sometimes even emotion. So why is natural language processing so hard? Well, language might feel natural to us humans because we learn it as toddlers and we constantly use it, but it's a minefield for machines. And the reasons is because of ambiguity. So you could say something like, I saw the man with the telescope, and the machine might be trying to figure out, well, did you actually use a telescope or did the man have it? And then there's issues with context. So you could say something like, I'm on fire, and that could mean you're literally burning up, or that could mean that you're doing something amazingly well. Then we have idioms and slang. So you could say something like spill the tea, or I'm about to hit the books, or break a leg. And to a machine, that could absolutely make no sense. Then there are synonyms and homonyms. So you could say the word bank, and that could mean a financial institution, or it could mean the side of a river. So when it comes to computers, they're really good at math and logic, but understanding all the weird quirks of human language, that takes some serious AI muscle. All right, so let's go over the building blocks of natural language processing. So before we explore applications like chatbots and translation, these are some of the core techniques and components that make NLP tick. The first is called tokenization, and this is breaking down a sentence into smaller parts or words or phrases. So we have the example of AI is awesome. You will break that down into AI, then is, and then awesome. Then we have what is called part of speech tagging. And this is where the computer will identify whether a word is a noun, verb, or an adjective. So if you say she plays the piano, then you need to identify she, which is the pronoun, plays, which is the verb, the, which is the determiner, and piano, which is a noun. You have what is called name entity recognition. And this is when you're finding names of people, places, brands, etc. in text. So you could say Apple is releasing a new iPhone in California. Well, Apple will be the organization, iPhone will be the product, and California will be the location. You also have what is called sentiment analysis, and this is used for determining the emotional tone behind text. So you could say something like, this movie was amazing, which would be positive, or you could say something like, I hated the ending, and that will denote a negative connotation. You also have what is called lemmatization and stemming, and this is reducing words to their root forms. So you take the word running, runs, or ran, and the root word is run. Then there's syntax and parsing, and this is understanding grammar and sentence structure. And then there's language modeling, and this is predicting what words come next in a sentence based on context. And this is how tools like ChatGPT write fluid, human-like text. So all of that are essentially the basic building blocks of natural language processing. All right, so modern natural language processing isn't just about rules and dictionaries. It's about machine learning. So instead of programming every single rule, we now feed massive amounts of text into models and let them learn patterns. And there are two major approaches. The first is traditional machine learning plus natural language processing. And this uses algorithms like decision trees or a naive Bayes. And this requires feature engineering where it manually selects what to analyze, like word frequency. And then you have what is called deep learning plus NLP. And this uses neural networks, especially transformers, which we'll talk about in a second. And it automatically learns features from data. And this powers modern tools like ChatGPT, Google Translate, and much more. Speaking of transformers, so transformers are a deep learning architecture that was introduced in 2017 that completely changed natural language processing. So transformers, what they can do is they can handle long range dependencies in text, like understanding that the cat mentioned 20 words ago is still relevant. It can also work in parallel, which makes training it much faster. And it can understand context and attention mechanisms to where they pay attention to which words matter the most. And the popular transformer based models include the following. The first is called BERT, and that stands for Bidirectional Encoder Representation from Transformers. And this is great for understanding language. Then you have GPT, the one that we all know, and that stands for Generative Pre-trained Transformer. And this is great for generating language. So now let's go ahead and shift gears and look at how NLP powers one of the most visible and fun applications, and that is chatbots. So you probably chatted with a bot if you've ever asked a question on a company website, tried to book a flight online, or used a digital assistant like Siri or Alexa. So exactly what is a chatbot? Well, a chatbot, this is a computer program designed to simulate conversation with human users. And some are simple and rule-based, while others like ChatGPT are advanced and use deep learning. And there are two main types of chatbots. The first one is called a rule-based chatbot, and this follows scripted flows and it has limited responses. So an example will be something like press 1 for billing or press 2 for support. Then you have AI-powered chatbots, and they use natural language processing and machine learning to understand input and generate responses, and they can handle free-form language, and they essentially get quote-unquote smarter over time. Now, here's how smart chatbots work step by step. So, the first step is called intent recognition. And this is where it figures out what you want. So, you put an input in there like, I need to change my flight. And the detected intent will be, you need to change your flight. And then there's step 2, and this will be entity extraction. And this is where it finds key information. So, in your input, you might put something like, change my flight from New York City to LA on Friday. And then the entities that it identifies is New York City is the origin, LA is the destination, and Friday is the date. And then the next step is called dialogue management. And this is where it decides how to respond, where it might ask you something like, would you like to change the departure or return flight? And then there's response generation to where it replies in natural language, where it might say something like, okay, I've updated your departure flight to Los Angeles on Friday. And all of this happens in a few seconds, thanks to natural language processing magic that's taking place behind the scenes. Now, another fascinating application of NLP is language translation. So imagine typing a sentence in English and getting a perfect translation in Spanish, Japanese, or Swahili in a matter of seconds. Now, we take all of that for granted, but this can be incredibly complex. So let's talk about the challenge of transition. So languages, they are wildly different. Word orders vary. So in English, you might say, I eat sushi. But if you did a direct translation to Japanese, instead of you saying, I eat sushi, it'll come out saying sushi, I eat. And then some languages have genders, some are formal versus informal, and some have unique grammar rules. And then also there are cultural nuances that can change meanings. Now let's walk through how translation systems evolve. So we have what is called the rule-based translation, and this used grammatical rules and dictionaries, and this required tons of human effort, and it was not very flexible. Then we have what is called statistical machine translation, and this learned from bilingual texts. It analyzed which words usually map to which, and it still struggled with grammar and context. Then we have what is called neural machine translation, and this uses deep learning and neural networks. It can translate entire sentences, not just word by word. It can capture meaning and context, and it is much more fluent and natural. So the most famous example would probably be Google Translate, which now uses neural machine translation, and this gets better with every sentence that you feed it. All right, next let's quickly talk about transformer-based translation. So modern translation systems that use transformer models just like chatbots. So here's the basic idea. So you have an encoder, and this reads the input sentence like you saying, I love learning. Then there's the decoder. So this generates the output sentence in the target language to where it'll transform I love learning into its French equivalent. Then you have what is called an attention mechanism, and this ensures the right words are matched. So the word love in English, this will map to the word adore in French. And because these models are trained on massive amounts of bilingual data, they get surprisingly good at capturing nuance and even capturing slang. All right, so let's go over some real world examples of how natural language processing takes place every day in your life, even if you don't realize it. So we have email spam filters. So NLP, this helps filter messages based on text analysis. You have autocorrect and predictive text. So your phone guessing what you'll type next, that's natural language processing. Voice assistants, so Alexis and Siri, they rely heavily on NLP to interpret your speech. It can be found in customer service. So you have automated agents that handle questions in retail, banking, and tech support. They're using NLP. Then you have sentiment analysis tools. So brands, they can monitor Twitter or reviews to track how customers feel. All of that is natural language processing. And here are some ethics and challenges associated with natural language processing. So the first one is bias. So if models are trained on biased data, then they're going to produce biased outputs. So for example, they might associate certain professions with a particular gender. Then there's privacy concerns. So chatbots and translation tools, they may process sensitive user data. So we need to figure out, how do we ensure that that data is being kept private? Then there's misinformation. So generative models, they can create fake news or misleading content. And then there's misunderstanding context. So even advanced natural language processing can misunderstand jokes, sarcasm, or cultural context. And that's why researchers emphasize responsible AI development and regular audits. So exactly what is next for natural language processing? Well, the field of NLP is moving fast. And so here are some exciting frontiers. So you're going to have multilingual models, and this will be one model that understands dozens of languages. You're going to have emotion-aware chatbots, and these are going to be bots that detect your mood and respond empathetically. They're going to have AI writing assistants. So tools like Grammarly, they're already out there where they can help you create content. They're going to have voice plus text integration, where it's going to blend speech recognition and NLP to create richer interactions. And as these tools get smarter, so does our need to understand them, which is exactly what you're currently doing right now by watching this video. All right, so here are all the key takeaways. So natural language processing isn't just about talking to machines. It's about creating a world where machines can talk to us, understand us, and even help us communicate across cultures and continents. So whether you're chatting with a bot, translating a phrase, or just enjoying autocorrect saving you from embarrassing typos, NLP is quietly working in the background. And as you continue your AI fundamentals journey, just remember, every great AI conversation starts with a simple goal, and that is understanding each other. And so with that being said, now you have a basic understanding how natural language processing works. All right, so let's do some check on learning. So the first question is, what is the primary goal of natural language processing? Is it to translate computer code into human readable formats? Is it to enable machines to understand, interpret, and respond to human language? Is it to store large amounts of text data in databases? Or is it to create artificial emotions in chatbots? And the correct answer is, it is to enable machines to understand, interpret, and respond to human language. So NLP, this is a branch of AI that focuses on allowing computers to understand and work with human or natural language. Its goal is to bridge the gap between human communication and machine understanding. Next question. Which of the following is a common ethical concern with NLP-based chatbots? Is it slow processing speeds? Is it the use of outdated language models? Is it bias in response based on training data? Or is it the inability to store user data? And the correct answer is, it is bias in response based on training data. So NLP models learn from large data sets, and if those data sets contain biased, offensive, or misleading information, the chatbot can replicate those patterns. And this raises ethical concerns about fairness, representation, and responsible deployment. And our final question, how does NLP support language translation applications like Google Translate? Is it matches words to images stored in the database, or it relies entirely on rule-based dictionaries, or it analyzes sentence structure and meaning to generate accurate translations, or it randomly generates text based on user preferences? And the correct answer is, it analyzes sentence structure and meaning to generate accurate translations. So NLP uses techniques like syntax parsing, semantic analysis, and machine learning to understand sentence structure and meaning. And this enables more accurate and context-aware translations between languages.